Thank you, Dr. Joe. Chapter 4 is about the future of digital solutions, climate crisis, and planetary emergency. Before we talk about the future, let us briefly reflect on the history and the evolution of digital solutions as well as the climate crisis. It was widely believed that prior to the Industrial Revolution, humans had a few basic needs and therefore led an environmentally friendly lifestyle with minimal harm to the planet and its ecosystems. However, with each stage of the Industrial Revolution, our needs and lifestyles grew increasingly complex. We started utilizing Earth's limited resources more extensively, leading to escalating environmental pollution and ultimately resulting in the current climate crisis, which we now face as a global emergency. The first industrial revolution, believed to have occurred around 1760s in the 18th century, was primarily driven by the discovery of steam and hydropower driven engines and mechanics. In the second industrial revolution, or the IR2, took place more than a century later than the initial, around 1870 in the 19th century. This revolution was mainly characterized by the mass production of human necessities through electricity-driven processes. The third industrial revolution, or the IR3, happened somewhere around in the 1960s of the 20th century, just about 100 years after the IR2, marked the arrival of digital solutions and the binary era, and was preliminary propelled by the automation of mass production through computers and robotics. After that, the fourth industrial revolution, or the IR4, came relatively quickly, just about 30 years after the IR3, around the year 2000, the very beginning of the 21st century. This revolution was mainly driven by the data sciences, the internet, and the mobile technologies. As evident, the time gaps between these industrial revolutions have been narrowing down, and now we are entering a rapidly transforming era of a fifth revolution, being driven by big data, leading to artificial intelligence and highly advanced robotic systems. But here is the problem. Even though we are in the era of a fifth revolution, we still rely heavily on the fossil fuels that have been using since the first revolution, as shown by the bottom pink arrow. The small green arrow represents the recent trend of sustainable energy sources. But this is the real world scenario of the above two arrows. As you can see, since the third digital and binary driven revolutions around 1960s, the human global energy demand, or the consumption, has also been increased very rapidly. That very high, continuously rising energy demand, still about 95% relies on non-sustainable or non-renewable energy sources like fossil fuels such as coal, crude oil, natural gas, and traditional biomass like wood, which was rapidly depleting since the first revolution. Although there is a growing trend, still only a tiny portion of the world's energy needs comes from sustainable or renewable sources like solar, wind, hydropower, etc. We rapidly need to find ways to use and store sustainable energy sources because our demand for energy keeps growing. Also, it's important to reduce our energy needs while finding the ways to meet them with sustainable sources. Next, we will explore important keywords and trends that can enhance our understanding of the future of digital solutions. Multidisciplinary digital solutions. Multidisciplinary digital solutions are approaches that combine different areas of expertise to tackle complex problems using digital technologies. These solutions are built upon key pillars such as data science, ecology, health, engineering, social sciences, and politics. One area where multidisciplinary models are crucial is in addressing climate change and related environmental and health issues. Given the interconnected nature of these technologies, a multidisciplinary approach becomes an essential tool. Big data. Big data refers to data sets that are too large or complex to be managed using traditional data processing methods. It is extensively used to study climate change and its impacts, as well as various issues in other sectors. Analyzing big data poses several challenges. These include capturing the data, storing it efficiently, analyzing it effectively, searching for specific information, sharing and transferring it securely, visualizing the data, querying it for insights, ensuring information privacy, and identifying reliable data sources. Dealing with big data requires significant computing power and storage capacity, which is why big data centers are essential. However, it is important for these centers to adopt green and sustainable solutions to minimize their environmental impact. By embracing eco-friendly practices, these big data centers can contribute to a more sustainable future. AI, or the artificial intelligence. Artificial intelligence refers to the ability of machines to perceive, synthesize, and infer information similar to how humans or animals do. It enables machines to perform complex tasks and make decisions based on data and algorithms. One significant advantage of AI is its ability to simplifying big data analytics. By automating intricate analytical tasks, AI streamlines the process of extracting insights from large and complex datasets. AI can also be used to gain a better understanding of climate changes and planetary emergencies. It has the potential to analyze vast amount of data, identify patterns, and make predictions about future scenarios. This can aid in developing new and improved solutions to mitigate the impacts of climate change and address planetary challenges. Quantum computing. Quantum computing is an emerging field that combines computer science, physics, mathematics, and quantum mechanics to solve complex problems faster and more efficiently than traditional information and communication technologies. One of the existing possibilities of quantum computing is its potential to accelerate the discovery and development of new green computational technologies. By harnessing the power of quantum systems, researchers can explore innovative approaches for sustainable energy production and storage. This can lead to advancements in renewable energy sources and more efficient methods of addressing climate change. Furthermore, Quantum computing offers the potential to enhance strategies for climate change mitigation. Its computational capabilities can aid in simulating and modeling complex environmental systems, helping us better understanding the impacts of climate change and develop effective strategies to mitigate its effects. Collaborative digital tools and future platforms. Collaborative digital tools and future platforms are essential for addressing the challenges of climate adaptation and mitigation. A lack of collaboration can be a significant barrier in tackling the climate crisis. To effectively combat the climate crisis, it is crucial to have global, regional, and national governmental collaboration in both technological as well as political aspects. Working together, these entities play a key role in implementing strategies and solutions to fight against climate change. Digital tools and platforms facilitate interaction and collaboration among multiple partners. By using these tools, organizations can enhance innovation and create new solutions to complex challenges. These platforms provide a space for collaboration, idea sharing, and coordination, enabling stakeholders to work together more efficiently. The COVID-19 pandemic has accelerated the development and application of digital tools for collaboration. The need for remote work and virtual communication has pushed the advancement of these technologies. As a result, digital collaboration tools have become increasingly accessible and user-friendly, enabling effective collaboration even when physical proximity is not possible. Future risks and governance requirements. In the future, there are risks associated with the use of new technologies and collaborations. While these novel systems can have positive effects, they also have the potential to be used in ways that can harm society and the humanity. It is important to ensure that the risks associated with these technologies are manageable and do not have a negative impact. To address these risks, it is crucial to establish a global governance framework. This framework will help to minimize both current and future risks. By developing and adopting this framework, we can effectively manage the potential negative consequences of new technologies and collaborations. It will provide guidelines and regulations to ensure the responsible and ethical use of these innovations, safeguarding the well-being of society and human as a whole. We are currently in the era of rapid transformation of the fifth industrial revolution, where technologies like big data, AI, and potentially quantum computing are shaping our future. These digital solutions have surpassed human capacity to handle big data and resulting big information, big knowledge, and big intelligence. They are also gaining more and more ability to make decisions and even replicate themselves. However, it's important to note that the majority of these digital solutions still rely heavily on fossil fuels as their primary energy source. While digital tools offer solutions, they can also contribute to the challenges we face with the climate crisis and planetary emergency. Therefore, it is our responsibility and duty to ensure that these digital solutions are directed towards a more sustainable manner, and it is crucial to harness the potential of digital solutions to mitigate the negative impacts and create a more sustainable future for everyone. It's our wish the next sixth industrial revolution will be a sustainability driven solution with the within the near future, perceiving the planet Earth for the future of all living things in our ecosystem. Thank you.